Hi girls, today we will start with the last section, section 4, torque and simple machines. It is the last section in our chapter, circular motion. Objectives: distinguish first between torque and force, calculate the magnitude of a torque on an object, identify the 6 types of simple machines, and calculate the mechanical advantage of a simple machine. Today's work is only about the new concept torque. Before we start with torque, we will learn about the rotational and translational motion. You know for sure, girls, with the word translational, it means linear motion. In the previous sections, we talked about uniform circular motion in all of its details. We talked about an object that's orbiting another object. We talked about its tangential speed, centripetal acceleration, centripetal force. Okay? Now, consider a tire on a moving car or a tire of a bicycle, for example. A translational motion, it's the movement of the center of mass. For example, when you have a tire of a car or of bicycle and you just hold it and you move it from position A to position B. In this case, here the center of the tire is just moving a specific distance. So we classify the motion of this tire as translational motion or linear motion. Right? But when we rotate the tire around its fixed point in the center, around its axis of rotation, we say that the tire here undergoes rotational motion. Let's see this video to understand what I mean.
This bicycle wheel is in rotational motion, but not translational motion. This bicycle wheel is in translational motion because its center of mass is in motion. This bicycle wheel is in both translational and rotational motion.
Okay, so always in order to have rotation, the rotation must occur around a center. We must have a center for this rotation. Okay, another example for rotational and translational motion: when a bowling ball strikes the pins, you know that some pins they will fly in the air, some pins they will just fly backward. So the pins that fly backward, their motion is linear, but the pins that fly in the air or spin in the air, their motion is rotational. Okay, so in physics, usually when we have like any situation that includes both rotational and translational, what do? We separate them. We study each one alone. Okay, in this section we will focus only about what? Rotational motion. Okay, the title of the chapter as a whole is circular motion. So in this section we are going to focus about rotational motion. You will see that the rotational motions that we see in our everyday life situations are caused by something called torque. Let's see what is torque. First, I will remind you about the definition of force, because torque is a result of force. It's caused by a force. Force, you know that it is any pull or any push you exerted on another object. We took it from grade 7 and we talked about it during this year in more details than 7. Okay. So the force you can exert it here, like the force exerted here by the hand on the wrench. Okay, this force here, girls, it causes, as you can see, the wrench here to rotate. Why? Because this force here, it's applied on the wrench around what? Around a fixed point called pivot. So when you apply a force, okay, around here a pivot or a turning point, what is the pivot? Pivot is a fixed point about which the object turn. Okay, like for example the hinges of the door, like seesaw, the pivot in the middle of the seesaw. Okay, the seesaw, it turns around this pivot. The hinges of the door rotates in and out around the hinges. Okay, so this point is very important in order to have rotation. So that's why at the beginning we said rotation. In order to have rotation, we must have the center or here pivot, turning point. Okay, so what is torque? See this turning effect? The effect here caused by the force applied, it is the torque. Okay, so torque, it is the turning effect of a force. So every force exerted on an object that can turn, it has this force, it has a turning effect. This turning effect is the torque. So torque is the quantity in physics that measures the ability of a force to rotate, or we can say to accelerate an object around some axis. Okay, so the pivot here, the line that passes through the pivot, we call it axis of rotation. Okay, let's continue. So now we will talk about the factors that affect this torque or this turning effect. And the most common example is the door. Okay, so what do you expect? The first factor is the force, because torque is caused by force. Okay, so the larger the force you exert, the more you can rotate the object, so the more torque you apply. Okay, so here, as you can see, there is a strong man who is exerting a large force on the door, but the door still cannot open. So there is another factor other than the force. Let's see what is it. Okay, so the first factor that affects the torque is the force, amount of force, value, the magnitude of force. The larger the force, the more you can rotate an object, and therefore you are applying more torque. Okay, the other factor is the distance. Distance from where to where? It's the distance from the hinges. The hinges are here, girls. So the line that passes through the hinges is called the axis of rotation. So always the line that passes through the pivot or hinges is called axis of rotation. Okay, so usually when we open a door, we open it from the handle, and the handle, where is it placed? It's placed at the farthest side on the door from the hinges. Okay, so as you can see, this is the distance between the axis of rotation and between the force that you are applying. You are applying force where? Here. Look, this man is not as strong as this one, but he is applying a force here at this point, at the point which is far from the hinges, not here near the hinges. Okay, so another factor we have to take it into consideration is the distance, the perpendicular distance from the pivot, from the axis of rotation to the point where the force is applied. So all girls, you have to understand what is, not only it's not D and you write D and that's it. No, you have to understand the meaning of this D, because it's very important. Okay, so it is the distance, the perpendicular distance from the hinges to the point where the force is applied. This is another example. This is a wrench. For, let's say that you want to unscrew a bolt. Can you unscrew it like with your hands? It's very hard, right? Usually what do we use to unscrew a bolt? We use a wrench. Okay, so using the wrench, usually, so we put our hands where? On the on the side, the farthest side from the pivot. The pivot is where? Is here. Okay, so the line, again, the line that passes through the pivot is called axis of rotation. Okay, and we apply the force here. Let's say that we are applying the force upward. We are moving our hand upward. Okay, so also here, girls, the line along which the force is applied has a specific name. You are applying the force along this line, right? So this line is called line of action of force. Okay, the line of action of force, because the force is applied along this line. Okay, now what is the distance? So see, distance is the distance from D, is the distance from the pivot to the point where the force is applied. Okay, let's say that I want to increase the torque. I want to increase the rotation so I can unscrew the bolt easier. There is a way. What is it? There is a way, and it is by using something called cheater bar. See, this cheater bar, they place it girls on the wrench to make it longer, okay, to make it longer with more length, okay. And now by making the wrench longer, and you apply the force here, and the pivot is where is here, okay. So look at the distance now from the pivot to the force, distance d, from the axis of rotation to the line of action of force, okay. Now it's more, it's longer, therefore the torque or the turning effect will be more, okay, and it will be easier to unscrew here the bolt. Clear? So till now we learned about two factors. What are they? The force and perpendicular distance. Okay, see this video. It's not working. Yes.
And error. You have honed your ability to walk through a door. When you approach a door, class, what do you look for?
The handle.
And the handle is located where relative to the hinge, which is the axis of rotation?
The handle is far away from the hinge.
Right. The handle of the door is about as far away from the axis of rotation or hinge as the handle can get on the door. When you open a door, you push near the handle. You have learned not to try to open the door by pushing near the hinge or axis of rotation. Let's talk about what.
Okay, girls, this distance from the pivot to the force, line of action of force, is called lever arm. Why? Because this distance, the more, like the longer the distance from the pivot, it gives you the extra leverage you need, the extra power you need. So that's why this distance therefore is called lever arm, or in other books is called effort arm, okay. But usually in our book we will use the word lever arm, okay. Now let's continue. Let's say that you are exerting a force parallel to the here to the distance. Will this force, do you think, will it cause any rotation? Will it cause or lead to any torque?
One last example of how you will never try to open a door. Bo, why will you never try to open a door by pushing on the side of the door like this?
So for sure, girls, you will never try to open the door like this, like pushing on the side of the door. Why? Because no matter here how hard you push, okay, your push or your force is with the same, is parallel to the distance, okay, to the distance till the hinges. So here this force, it doesn't cause any turning effect or rotation for the door. Now let's say, girls, that you are applying a force, but this force, it's not perpendicular and it's not parallel. You are applying a force at an angle like this.
The thing we have learned to never do to try to open a door is to push at an angle like this. Bobby, why will we never try to open a door by pushing at an angle like this?
So girls, also you will never try to open the door by pushing like this at an angle. Why? Because this will make the process harder. And here you are applying force F, and maybe it's a great force, but you feel that it's hard to open the door, or like any other object around a pivot, okay. Why? Because not all of the force that you are exerting is going to cause a turning effect or a torque. Not all the force that you are exerting is going to rotate the door, only the component which is perpendicular. So only this component is going to what? To cause the door to rotate the door, okay. Because I explained in the previous slide that the component which is parallel to the distance, it doesn't make anything, it doesn't cause any rotation, okay. So here, when the force is at some angle, only the perpendicular component causes the rotation. Okay, so here also we have another example about the relationship between the torque and the angles. Here you have a cat which is trying to leave its house, okay, by pushing on the door. It's pushing on the door by its nose. Here the door was closed, so it was easy for it to push it. See the force, this is the force, and this is the distance always measured. Lever arm, it's the perpendicular distance from the pivot. Where is the pivot? Here, because the door is rotating around this pivot, is rotating freely around this pivot, around this fixed point. So the pivot is the fixed point around which the door rotates. Okay, so this is the lever arm. Because here it's the perpendicular to the force, so it's easy, we have the maximum torque. But here, look, the door is already opened till here, okay, because the cat already opened it till here, okay, and now the cat is trying to open it more. Okay, so the cat is still applying force in this direction, but let's see the distance now. The distance always from where to where? You revise the equation in your mind. It's the distance from the pivot to the point where the force is applied. Okay, but it is what we forgot, the first one, the first word. It is the perpendicular distance. It is the perpendicular distance from the pivot to the force. See, the force is applied along this line, right? So you can extend it. I told you at the beginning, the line along which the force is applied is called line of action of force. Okay, so you start, when you talk about distance and when you draw the distance on your picture, okay, on the picture you have, you start from the pivot, the fixed point, and you draw a perpendicular distance to the line of action of force. Line of action of force, you can extend it. So see, this is the distance that we have to put it in the equation. This is the lever arm. I said the torque is equal to force times lever arm. Okay, so this distance, this is the lever arm, the correct one. It's equal to what? It's actually equal to d times sine theta. We will prove it in another example. Okay, so here also the door is open more and the cat still trying to open it more. So the force exerted in this, and if I want to find the lever arm, I start from the pivot and I take it perpendicularly to the line of action of the force. So this is the lever arm. This is the lever arm. Okay, so in each example the cat is pushing on the door at the same distance from the axis. Okay, in the first figure, as you can see here, the cat is exerting a force which is perpendicular to D, but here in the second and the third picture, the angles are less than 90 and the door will still rotate but not as easily. Okay, so when the angle that we have it is less than 90, it means less than the right angle. Okay, there will still be a torque, there will still be a turning effect, but not as like when the force is perpendicular to the displacement, when the angle is 90. Okay, so the maximum torque, we have it like here. Okay, to produce now, if we want the cat to produce the same rotation in these cases, so the cat must exert here a larger force than here, and must exert here larger force than here and here. Okay, so the conclusion now, the factors that affect the torque, what are they? It is the quantity of the force applied, and where the force is applied depends if it's applied near the pivot or far from the pivot. Okay, and depends also on the angle at which the force is applied. If you are applying the force perpendicularly to the axis of rotation, so you will get the maximum torque. But when you apply the force at an angle, okay, so here you will get less torque. The equation that we will follow in this lesson, what is it? Already we said it. Torque is equal to force times lever arm. Lever arm is very important concept. It is the perpendicular distance from the pivot, as we said. Look, girls, so here you have this wrench, for example, and this bolt, and you want to find the lever arm. You start from where? From the pivot, okay, and you draw the line of action of force first. What is the line of action of force? The line along which the force is exerted. The force, as you can see here, it's exerted along this line, right? Okay, the force exerted along this line. Okay, so now the lever arm, we said it is the perpendicular distance, so you draw perpendicular line from the pivot to the to the line of action of force. So this is my lever arm, so this is the distance that I will use it in my equation. So torque is force times lever arm. Okay, so in case, girls, you have the length of the wrench and you don't have the lever arm, you have the length of the wrench, it's given as D, and you have the angle between D and F. How can you find the lever arm? So see, what is sine theta? So sine theta, we know it's opposite over adjacent, right? This is the, opposite over hypotenuse. So this is the equation. Now, what is the opposite to theta? It is our lever arm. It is the lever arm, the one that I wanted. It is the lever arm. Okay. What is the hypotenuse in this right triangle? It is D. So divided by D. So what is the lever arm, the one that I care about? It is D times sine theta. So that's why we replace lever arm by D times sine theta, because usually they give us the length of the wrench and they give us the angle between the wrench and the force applied. Okay, so I hope that it's clear. You have to repeat it more than 1-2 times to get it, because it's a new concept for you. This we will complete it tomorrow. Thank you.